Okay, today edition. This is my system, and I want to show some upgrade and experiments I conducted, and some improvements and what I understand about it. Here is my 12-volt brushless motor. Here is my generator. Here is my meter, and here is a 12-volt battery. And if you see here, you will see a lot of bunch of capacitors, different value. Both of them are microfarad capacitor. This one is a 50 UF, 30 UF, um, 20 UF, 10 UF, and here usually is 24 UF. That's mostly what this generator usually comes with. So, like if you look at here, you see my element very perfect, very perfect. The reason why I decided to use this belt is I saw that it will minimize the vibration, and even though there is a misalignment, it won't occur in the generator or motor, it will just occur in the fan belt. So here is my meter connected at 700 volts. So let me on it. So let me connect my DC motor. Can it take a while for it to start? Because that's how they program it. It is a brushless motor. So you can see this 7 volts you display here is because of the uh, permanent magnet in the armature, in the lotto. Some people call it armature, some people call it a lotto. So that's why it's displaying this 7 volts. So now, um, this capacitor is a 24 UF. I don't know if you can see it very well. 24 UF, and this one is also 24 UF, but there are different value and practical. So let me show you. Remember these things, they are the same 24 UF, 24 UF, but in practical it is different. So which can cause a lot of confusion. Let me connect the Zeta terminal. I have already connected one. Let me connect. This one is showing me 17 volts, 17 volts, 16, 17 volts. So now let me connect the same 24 UF capacitor, so you see the difference. So do you see the difference now? This one gave me 21, 22 volts. So, but at the same volt, the same value, but in practical, it is difference. Understand? So now I will have to connect my clamp meter and set it to DC to know how many current the motor is drawing. It is on DC now, drawing from the, so you can see 2.6 amp, 2.6 amp. So let me remove it. Now this is a 50 UF capacitor. This is 50 UF capacitor. I'm gonna test all these capacitors to see how far. So this is 50 UF. I'm gonna connect it now. Just watch. You see there is a drag, and current consumption went up almost 24 amp. So Let me test this 30 UF. Fourteen amp. 14 amp. Is a drag here. So let me test 20 UF. 12, 11, 12 amp. Now let me test this 10 microfarad capacitor to 14 volts. So let me test this 15 UF. 15 UF. That's 36 volts. So now imagine 15 UF, 15 UF. That is cash. 15 UF give us 35 volts. Why 24 UF give us 20 something volts? Let's check it again. 24 UF. Okay, this one, the previous one, give us 16 UF, 16 volts. Sorry, 16 volts. So this one is what give us 20 something volts. Yeah, 21, 22 volts. So what I want to demonstrate here is that sometimes it doesn't matter about what they write on the body. Understand? So imagine 15 UF give more volts than 24 UF. Understand? So that is it. So I have to make some amendments either from the winding so that the voltage will match to 220, 230 volts. So I have to add some capacitor, small capacitor to meet up the value, because this previous test is giving me higher voltage. Even this one gives me higher voltage, but I just want to confirm something from it. Just want to confirm something from it. So you see difference. The consumption from the motor has reduced while the voltage has seemed to be maintained. So small value that reduction, the voltage will match to 220, 230 volts. So you can see 7, almost 8 amp. But this 50 UF capacitor consume almost 40 something amp. I mean 20 something amp, sorry to say 24 amp from the input. So imagine using this capacitor connecting here, it will consume this battery faster, and then it will generate a lot of heat in the system. So can you imagine
So there you have to be a lot of deduction then, so that the system will match to 220 and the current consumption be able to come down. So you can see it. So in terms of these two capacitors, they are identical, and this one is 24 UF, this one is 24 UF, but both of them are not the same value. So it will cause a lot of confusion in uh, such project like this. It cause a lot of confusion. Cause a lot of confusion. You know, if you can see clearly. So they are the same identical but different value, but the same 24 UF. So let me disconnect this small capacitor. It will go back to normal speed. The reason why this thing occurs is because the rotor inside is feeling less magnetism, so the motor can be able to rotate it more freely. So that's why there is a less consumption. Likewise, this 50 UF that has a lot of value. So once you connect it, this rotor that is rotating will feel more strong magnetism. So the motor see it as a very strong load to rotate it. That's why it consumes a lot of current here from here. So the 15 UF has now come back to normal value, which is 50 something to 60 volts. Let me connect this one back again. So that's how it is. Thank you for watching.